Hello, we are going to go through our topic 6 review as requested. So starting off, it says to give the domain, range, intercepts, asymptote, and end behavior of the function. So our domain for these are always going to be, I'm going to do it out here to the side. Domain is always negative infinity to positive infinity. Your range depends on whether there is a horizontal shift, which would be determined by, adding something out to the side. And if there isn't one, then your range for these is going to be 0 to infinity, which then gives our asymptote. I'm going to skip the intercept for a minute. So we're going to have an asymptote at y equals 0. And then our intercepts are, remember, determined by a, so it's going to be 0, 4, and there's only a y-intercept, not an x-intercept, because the x-axis is an asymptote. And then the end behavior is that as x approaches infinity, y approaches infinity, and as x approaches negative infinity, y approaches 0. So these are the EBs, the end behaviors. For number 2, this asks, does the function represent exponential growth or decay? For that, you look at your B term. B in this case is between 0 and 1, so it is decay. If B is greater than 1, then it is growth, just as a precursor, but this one is decay. So now for 3, we're going to graph the function. 4 tells us that our y-intercept would typically be at 4, but we have a downshift, so we're going to move it down to 2, and then we have this shift right 1, so we're going to move it 1. So the most important point to move is that one, and then we draw. And then we also have to make sure we put it on our thing. Now remember, on test day, that question will be multiple choice. Question 4 says the population of turtles in a lake is estimated at 1,000. The population increases at 12% per year. What exponential function can you use to identify the monthly growth rate? So with monthly growth rate, we have our 1,000. We have our 1 plus 0.12. But what we have to remember to do is that we have to take this to the 1/12th and then to the 12t. And so what that does is that makes our annual growth rate, but we have to look at it that way. And so there we go. Okay, question 5 says Anjali invests a sum of money in a retirement account with a fixed annual interest rate of 6.9% compounded continuously. So with continuous compounding, we're looking at a PERT. So after 20 years, the balance reaches this. What's the amount of the initial investment? So we're looking for P in this one. So we've got 14,037.16 equals P, we don't know, E to the 0.0679, and then T is 20. So we're going to go back to Desmos. And okay, you guys know I'm going to forget everything. So 14,037.16. So start here. We need division. So we're going to do 14,037.16. And we're going to divide that by E to the 0.0679.
If you're in the building, please come to the front office. Miss Kelly Hayden, if you're in the building, please come to the front office. Thank you.
Yep, see, I'm doing this first thing in the morning. Ha ha ha. So that means that we started out with 3610 in our account. So P is 3610, $3,610. So question 6 says, Ryan invests a sum of money in a savings account with a fixed annual interest rate of 4.31%, compounded 12 times per year. That's monthly, peeps. After 10 years, the balance reaches this. What's the amount of the initial investment? So with this one, we're looking at A equals P times 1 plus R over N to the NT. So we have 12, 8, 55, 94 equals P times 1 plus 0.0431 over 12 to the 12 times 10. Oh, also how I got there is we divided both sides by this. And so on this one, we're going to divide both sides by this. So 12, 8, 55, 94. 12, 8, 55.94. Ooh, put your division bar in first so that it works. And then we're going to divide that by 1 less another division bar, 0.0471 over 12 to the 12 times 10. And let's make sure I have that interest rate right because I'm not sure about that. 431. So let me go back and fix that. So we started out with 8361 in our account. Continuous compounding, it's good stuff. Okay, so now for 7, we're going to logarithmic form. So we would write this as log base 64 of 8 is 1/2. Okay, 7, potassium has a half-life of 12.4 hours. How much of an 848 gram sample of potassium will be left after 62 hours? So with this, our rate is 1/2. So we started out with 848. We're going to have 1/2, and then we have done 62 hours after, but the rate is after 12.4 hours. So our amount left is 848. Our initial amount, 848, times, times, and I'm just going to put 0.5 because it's easier to type in. This 64, is that right? 62. 62 over 12.4. So we'll check that. Yep, we're there. And you'll notice that there is 26.5 grams left. So our amount left is 26.5 grams. 8 says how much money at 6% compounded continuously for 3 years will yield $1,000. This is very similar to number 5. So we're going to set that up. 1,000 equals A, or whoops, not A, P, don't want that either. Sorry. PE to the 0.06 times 3. So we're going to do, this one will be easy to remember as I come over here. So we do 1,000, division bar first, 1,000 divided by E to the 0.06 times 3. And we get $835.27. So P is 835.27. All right. 10 says you open a savings account and deposit $1,000. After 1 year of earning continuously compounded interest, your balance is $1,018.16. So for this one, we don't know the rate. So, and they give us the 2-year balance, but we really don't need that. So we know that after a year, we're looking at $1,018.16 equals 1,000 times E to the r times 1. So to solve for this one, we're going to start by dividing by 1,000. And then once we get that, we have e to the r equals 1018.16 divided by 1,000. Now notice I'm leaving this like this, and that's so we can keep our answer exact. So we're going to get ln of 1018.16 divided by 1,000 equals r. And the reason we chose natural log is because we have base e here. So we go here, ln of 1018.16 divided by 1,000. And our rate then is 1.79 or 1.80%. 1.8%. Because you have to change it from a decimal to a percent. Here we're going from logarithmic to exponential form. So we're going to have 14 to the negative 2 equals 1 over 196. Easy enough. Evaluating the logarithm, you can put this in your calculator, but I know that 5 to the third is 125. Evaluate, you can also put this, we're looking at what exponent we're putting 10 at, and we have to think how many times we move the decimal here. Again, you can put this in the calculator, but I know this is going to be negative 5. Okay, so this one is a solve the equation. To solve the equation, we have to go back to natural log. ln of 1/2 equals x. So we're going to put it in logarithmic form. So back over here, ln of 1/2 gives me negative 0.693. So this is going to be done. Okay, to graph this, remember logarithms start out here and go flat. And they typically have that x-intercept at 1. So we, again, just like we did for the exponential, we're typically here at 1, but we've shifted left 2 and down 4. So that's our point there. Boom, we're done. Make it look a little more flat. Oh, and our y, okay, I'm going to start over. Our asymptote is now at 2 instead of at 0. So I'm going to make sure we have our asymptote in the right place. Okay, this is graphing that log and its inverse. And so log base 3 of x, again, we're going to go through that y-intercept. And there's no shifts on this. So our asymptote is there, and there's our log. Now, the inverse, you've got to remember, is 3 to the x. And so it has that y-intercept here, and it gets flat and then goes up. And it has an equation there. Now, they may not intersect right here like mine did, but you can graph them on your calculator. Again, it's going to be multiple choice. Okay, 17 says find the average rate of change of this function. So we're going to have 10 minus 0. Oh, gosh. Keep doing that. Sorry. Over 6 minus 0.05. So we get 10 over 5, or 0.5, sorry, 0.5. 6 over 5.5, or 10 over 5.5. I'm not doing that in my head. So we get 0.1818 or 20/11ths, which I'm just going to leave it as 20/11ths. You know I like fractions. Then it says find the rate of change for 8 log 3 of x over that same interval. So we're going to do 8 log 3, or log of 3 times 6, and 8 log of 3 times 0.5. Well, little geometry review for you there. So 8 log 18 gives us 10.42. 10.042. And a log of 1.5 gives us 1.4. So now these are our y values. So we're going to do 10.042 minus 1.4 over 5.5 again. So 10.042 minus, what was that? I forget, 1.4. I'm recording an ed puzzle. Say hi to Miss Perkins, everybody.
Hello, kids.
And so that's 1.57. All right, so we are on to 18 now. Oh, so which one is greater? I think this one was 1.18. So our greater rate of change is on that log. Okay, now we're finding the equation of the inverse. So to find the equation of the inverse, we switch our x's and our y's. So we get x equals log base 5 of y plus 2. We need to rewrite this as an exponential. So we're going to have 5 to the x equals y plus 2. And then 5 to the x minus 2 equals y. Find the equation of the inverse here. X equals 4 to the y minus 4. I have log base 4 of x equals y minus 4. Log base 4 of x, and remember it's important for that x in parentheses, plus 4 equals y. So in both of these cases, here's the inverse there, and there's the inverse for number 19. Okay, for 20 and 21, we're just expanding the log. So this is going to be log base 7 of 18 plus log base 7 of x to the 4th, but we have to do something with this. So we're going to have log base 7 of 18 plus 4 log base 7 of x. And that is our final answer. Then here, this one's even easier. Log base 4 of x minus log base 4 of 15. And we're done. No exponents in that one. Okay, with 23, we're going to condense. So we're going to get log base 4 of x times x minus 2, which becomes log base 4 of x squared minus 2x. And we're done there. And then this one, we have to take care of that 5 first. So we get ln of x to the 5th plus ln y squared minus ln of 3. And then when we're writing them all together, anything positive goes on top and anything negative goes on the bottom. Boom, we're done. Okay, so now to solve these logarithmic equations, we have to condense them first. So this is going to be log of 3x equals 2. So we're going to get 10 squared equals 3x, because remember, if it's not written there, it's 10. So 100 equals 3x, so x is 100 over 3. And we're done. Not too bad, right? So here we have to do the same thing. We're going to condense this side. So we get ln of 4 times 3x minus 1 equals ln of 15. Then once we have both of those logs on the sides, they cancel. So we get 4 times 3x minus 1 equals 15. 12x minus 4 equals 15. 12x equals 19, and x is 19 over 12. Here we can change our base. So we can have 2 to the 5th to the 2x equals 2 cubed, because 32 and 8 are both powers of 2. So we have 2 to the 10x equals 2 cubed. 10x equals 3, and x equals 3/10. Done. Okay, now this one is going to require a logarithm. So we're going to do log base 13 of 73 equals 7x. Pop over to Desmos. And I have to actually use the function key for this one. So, whoa, that is also in the wrong spot. Guess we're up here in slot 5. I don't know if you guys can see that. So we're at log base 13 of 73. And we get that 1.67. And then we're going to divide that by 7. So I'm going to go back here. I'm going to put that whole thing in parentheses because I got to manipulate the Desmos and then put it over 7. So we get 0.239 as our x. And then finally, we are finally on our last one. The sales of lawnmowers T years after a particular model is introduced given by the function y equals 5,500 ln of 9t plus 4, where y is the number of mowers sold. How many mowers will be sold 4 years after the model is introduced? So t is time. So that is going to be our 4. So we're going to do 5,500 ln 36 plus 4, which is 40. 5,500 ln of 40 gives me y. And of course, I'm back in Desmos. ln, 5,500. 5,500 ln of 40 gives me 20,288. So 20,288 mowers. Oh, it does say to round to the nearest whole number. I didn't know if I needed to round up. Oh, I do. So that's going to be a 9. Where'd my eraser go? There we go. 9. So there is your final exam review. Good luck.